The Grumman Aviation Company began cooperating with the United States Navy at the end of the 1920s. At first, it manufactured floats for seaplanes, and later it began building its own aircraft, striving to use the most advanced technologies of the time. The first two seaplanes the company offered to the military were intended for reconnaissance missions. These machines had an all-metal construction and were equipped with retractable landing gear featuring a very original lifting mechanism. This mechanism attracted the attention of specialists from the Navy Bureau of Aeronautics. They understood that it needed to be used on combat aircraft to reduce air resistance and increase flight speed. Carrier-based fighters in particular required such landing gear. In February 1930, the leadership of the Bureau of Aeronautics proposed that Grumman consider the possibility of using retractable landing gear on Boeing fighters. However, the inventors of the mechanism, who immediately patented their creation, did not want to share their intellectual property and expressed doubts about the feasibility of modernizing a potential competitor's aircraft. Just a month later, Grumman responded by offering the Bureau its own project of a two-seat fighter with an all-metal fuselage, duralumin skin, and retractable landing gear. The project ideally fit the requirements of the recently announced Navy program to create a two-seat high-performance fighter. The new aircraft looked attractive compared to the fighters of Boeing and Curtiss, which had mixed fuselage construction and wooden fabric wings. The Grumman fuselage structure, assembled from duralumin profiles, was as strong as the steel tube fuselage of previous models and was in no way inferior to the design of more modern fighters. The fuselage gained even greater strength thanks to its duralumin skin. The wing frame was also duralumin, though its covering remained fabric. Significant reduction of drag was achieved thanks to the retractable landing gear, the smooth fuselage surface, and the enclosed cockpit. The latter feature especially appealed to pilots, as such a cockpit was still a novelty for carrier-based fighters. Preliminary calculations by Grumman engineers showed that the proposed aircraft would surpass any existing Navy fighter of the time. However, the new aircraft existed only in the imagination of its designers, in calculations, and in a few sketches. Therefore, skeptical Bureau specialists requested detailed drawings to build a scale model and verify the claimed characteristics in a wind tunnel. Preparing them took nearly a year. During this time, the designer selected the necessary engine, propeller, and estimated the cost of producing a prototype fighter. Tests of the built model confirmed the developer's calculations. On March 28, 1931, the Navy ordered one aircraft from Grumman equipped with a Wright air-cooled engine producing 575 horsepower. The military gave the machine its own designation. The fighter was to be armed with 3 standard caliber machine guns, 2 firing forward through the propeller and 1 for rear hemisphere defense. Construction of the prototype fighter began at Grumman's small facility in Baldwin, Long Island, New York. However, soon part of the Curtiss Company's facilities was transferred to Grumman, and the aircraft's completion took place in new, spacious workshops near Baldwin. The first flight took place on December 29, 1931. The fighter was immediately transferred to the Navy's Anacostia Air Base for evaluation by military pilots. The promising design fully justified the expectations of its creators. Its maximum speed reached 195 miles per hour, 7 miles per hour faster than the main carrier-based Boeing fighter. During testing, pilots made several minor remarks. Following them, the designers reduced the number of braces in the cockpit canopy glazing, reinforced the main landing gear struts, and reduced the number of cooling slots on the cowling that covered the fighter's nose section. The Navy Command accepted the aircraft, and on December 19, 1932, the Navy ordered 27 production aircraft from Grumman. The production fighters differed by external mass balances on the ailerons, which reduced control stick loads, the absence of frontal engine cooling shutters, and a modified tailwheel position with a reinforced strut. In May 1932, a new Wright engine producing 750 horsepower began to be installed on the aircraft under construction, which increased the maximum speed to 201 miles per hour. Thus, the fighter exceeded the latest Boeing fighter by 12.4 miles per hour, and the older model by 46 miles per hour. The predictions of Grumman's designers came true. After the completion of flight tests, the first prototype was modified to match the production standard and transferred to a squadron on the U.S. West Coast. In the summer of 1936, this fighter took part in secret experiments on using powerful light sources to reduce aircraft visibility in the air. During the tests, the darkest areas under the wings, stabilizer, and fuselage were illuminated by special lamps, which was supposed to make the aircraft evenly lit and therefore less noticeable against the bright sky. However, the light camouflage system did not prove sufficiently effective, and in the fall of 1936, the experiments were stopped. Serial production of these fighters began in April and ended in November 1933. 25 aircraft entered squadron service aboard the carrier Lexington, and one was sent to the Anacostia Air Base. At the beginning of winter 1935, the squadron transferred to the carrier Ranger, from which these fighters operated until 1936, when they were replaced by more modern models. Despite some shortcomings, the aircraft, nicknamed Fi-Fi by pilots, left a good impression. After these fighters were withdrawn from carrier aviation, 22 aircraft were transferred to the Navy Aircraft Factory in Philadelphia to be converted into training machines. Their arresting hooks were removed and dual controls were installed in the second cockpit. At the same time, all exhaust pipes were merged into a single manifold that directed gases downward so they would not enter the cockpit. All converted trainers were distributed among reserve units of the Navy and Marine Corps, where they were used to train naval pilots. The armament was not removed from the aircraft. On some machines, a radio compass was installed with wire antennas stretched between the lower and upper wing panels. By June 1940, only 15 serviceable aircraft remained in the units, and by December 1941, only 7. The last training aircraft was scrapped in July 1942. Even during the construction of the first prototype fighter, the Navy ordered a reconnaissance modification. Only minor changes were introduced into the design. To increase flight range, an additional 45-gallon fuel tank was installed in place of one of the machine guns. The aircraft was equipped with a more powerful engine, and the width of the cowling was increased, which had a positive effect on the fuselage aerodynamics. The first reconnaissance flight took place on August 20, 1932, and 10 days later it was sent to the Anacostia base, where acceptance flight tests immediately began. After their successful completion, the Bureau of Aeronautics ordered 34 production reconnaissance aircraft. Several further changes were made in the design of the production machines concerning the power plant, aerodynamics, and control system. The individual exhaust pipes of the cylinders were replaced with a common exhaust manifold. To reduce drag, the external aileron control levers were replaced with internal ones. The adjustable stabilizer was fixed rigidly. After all these refinements, the maximum speed of the production reconnaissance aircraft reached 206 miles per hour, which was 5 miles per hour faster than the fighters. The first production reconnaissance plane was delivered to the customer on February 15, 1934. The last, 34th machine was retained by Grumman as a prototype for the next modification. From the delivered aircraft, the Navy formed one reconnaissance squadron aboard the Lexington, while the remaining 7 aircraft were distributed among 7 different carrier units. These were 5 fighter and 2 bomber squadrons. At the end of 1935, the reconnaissance planes were withdrawn from combat units and transferred to shore bases in Navy and Marine Corps reserve units. The last production reconnaissance aircraft left at the plant was fitted with a power plant from a new generation fighter. For this purpose, the nose section of the reconnaissance aircraft was rebuilt and covered with the fighter's cowling. The purpose of this work was most likely the unification of power plants for carrier aircraft. The less powerful engine developed only 650 horsepower but had a significantly smaller diameter, which gave hope that the reduction in speed would not be too great. The aircraft made its first flight on November 26, 1934, and showed a maximum speed of 202 miles per hour. Military specialists considered this insufficient, and the test program was halted. In 1940, the airframe was transferred to the School for Junior Aviation Mechanics as a training aid. In 1934, the Bureau of Aeronautics announced a competition to create a new carrier-based reconnaissance bomber. 7 companies participated. 5 of them submitted monoplane projects: Brewster, Hall, Northrop, Douglas, and Vought. Curtiss and Grumman proposed biplanes. For their project, Grumman designers based their work on technical solutions tested on the previous reconnaissance aircraft. At the beginning of 1935, construction was completed on a prototype with a new engine and a new variable pitch propeller, which gave the aircraft a maximum speed of 215 miles per hour. This significant increase was achieved through aerodynamic improvements. The armament consisted of 2 machine guns, one firing forward, the other backward, and a 500-pound bomb could be suspended under the fuselage. The tests did not reveal any particular advantage of this aircraft over the Curtiss biplane, while the development of monoplanes was somewhat delayed. Therefore, the Navy decided to adopt the Curtiss aircraft. The Grumman prototype remained at the Anacostia base and was used for testing various onboard equipment. In the summer of 1939, the machine was scrapped. When the company completed serial production of fighters and reconnaissance aircraft, a number of parts and spares remained at the plant. The management decided to assemble from them a special machine for promotional flights. The aircraft received a civil registration number and made its first flight on September 28, 1934. Being assembled from spare parts, this aircraft differed from previous models with a completely new nose section housing an engine of 350 horsepower. After assembly, the aircraft was painted bright red and named the Red Ship. Until 1936, Grumman used this aircraft at various public events and air shows. During one demonstration flight, the machine attracted the attention of the famous Canadian pilot, sportsman, and businessman Howard Klein, who planned to profit from exporting aviation equipment to Latin American countries. As an official representative of the Canadian company Canadian Car and Foundry, he signed a contract for licensed production of the fighters in Canada under a new designation. According to the contract, Grumman was to supply ready-made parts for final assembly of the machines on the production line in Fort William, Ontario. After negotiations with the company's management, Klein purchased the aircraft as a prototype for future production. In October 1936, the company returned the machine to the plant for conversion to the new standard. A new Wright engine of 890 horsepower with the latest variable pitch propeller was installed, and the standard cockpit canopy was restored. On November 20, 1936, Howard Klein ferried the updated aircraft to Montreal, but on December 15, he had to return to the United States to demonstrate the machine to representatives of the Arms Procurement Commission of the Republican government of Spain, who wanted to purchase 16 fighters. In March 1937, Klein set off on a promotional tour with this aircraft. On March 17, 1937, he arrived in Mexico and then flew on to Nicaragua. On September 29, 1937, the tour was abruptly cut short. The aircraft fell into the sea due to complete fuel exhaustion near San Juan del Norte, missing the Nicaraguan coast by just a few miles. In the summer of 1936, components for assembling the first series of fighters arrived in Canada. Grumman sent 52 fuselages, 66 tail units, and 70 wing sets, with some parts manufactured by Brewster. Compared to the previous model, these aircraft were equipped with a Wright engine producing 890 horsepower, whose cylinders were covered by an aerodynamic cowling with an increased chord of 18 inches. The engine drove a Hamilton standard variable pitch propeller. The armament matched that of the earlier fighter. Additionally, 2 bombs weighing 110 pounds each could be suspended under the wing. As a result of Klein's flights, the Nicaraguan government purchased 1 copy of this fighter in Canada. Another machine was sold to Japan. Republican Spain, which showed great interest in the new fighters, could not buy aircraft directly due to agreements among the countries of the so-called Non-Intervention Committee. Therefore, the Republicans arranged a fictitious order for 50 fighters, allegedly on behalf of Turkey. The first 34 aircraft, shipped disassembled aboard 3 vessels, were sent to Turkey on April 2, 1938. When the time came for the final batch of 16 machines, the deception was uncovered and the fighters were returned to the factory in Fort William. One of these aircraft was successfully sold to Mexico, while Klein tried to place the rest in Canada. However, the Canadian Air Force was reluctant to adopt already outdated aircraft, and under various pretexts avoided negotiations with Canadian Car and Foundry. Nevertheless, in September 1939, after the outbreak of war in Europe, the Royal Canadian Air Force decided to purchase these fighters for use in coastal patrol duties. In December 1940, 15 aircraft, which received the name Goblin, arrived for service with the 118th Squadron of the Royal Canadian Air Force in Rockcliffe, Ontario. In the harsh Canadian climate, the Goblins performed poorly. All aircraft were only able to get airborne after winter ended. The squadron reached full combat readiness only by mid-June 1941. On December 12, 1941, these fighters were officially retired and replaced by P-40 fighters. 5 aircraft were retained for training flights, but after one pilot nearly suffered carbon monoxide poisoning from exhaust gases, flights on the Goblins were banned. 34 fighters arrived in Spain via France in the spring of 1938. After assembly and test flights, they were included in the 28th Group, consisting of 2 squadrons. The first was commanded by Captain Santiago Capilasa, and the second by Captain Diego Sanchez. Given their naval origin, the Spaniards nicknamed the aircraft Delphin. The Delphins were inferior to the Nationalists' fighters, and their main task was to strike ground targets. 3 aircraft from the 1st Squadron were sent to Teruel. 10 flew to the Ebro River area, while the 2nd Squadron operated in full strength in Andalusia. The combat debut of these fighters ended in complete failure. 2 biplanes made forced landings in enemy territory and were captured by the Nationalists. By the beginning of the summer Republican offensive in the Ebro River region, the Delphins had achieved nothing noteworthy, although they actively flew in Valencia, patrolling the coastline and providing air defense for Cartagena. Not a single enemy aircraft was claimed by the Spaniards. In August, 9 fighters moved to Extremadura in western Spain to provide air support for ground forces. At that time, the Nationalists managed to gain air superiority, which immediately impacted the losses of Republican aircraft. On September 1, 1938, a pair of these fighters engaged in combat with Italian Fiats from the 2nd Group. In the short engagement, both Republican aircraft were shot down. Between August 1938 and January 1939, the Republicans lost 8 Delphins, 1 in an accident, 2 destroyed on the airfield, 2 shot down, and 4 captured on the ground. In March, the remaining G-23 aircraft were transferred to Cartagena. The Civil War was nearing its end. The Republican Air Force was almost completely defeated, but this period proved the most successful for the G-23 Delphin. 1 pilot managed to shoot down a German He-59B seaplane. On March 22, 5 Delphins and 20 I-15 aircraft attacked Italian landing ships attempting to enter Cartagena harbor, inflicting serious damage on the aggressor. On February 6th, the last Delphin loss was Diego Sanchez's aircraft, shot down by a German Bf-109E. On March 30th, after the Republican capitulation, 5 G-23 aircraft flew to Algeria, where the Spaniards requested political asylum. Of the 24 G-23 aircraft possessed by the Republicans, 23 were lost. 3 shot down in air combat, 10 destroyed in air raids or accidents, 6 captured by the Nationalists, and 5 ended up with the French in Algeria, who later returned them to Spain. The remaining 9 aircraft were taken into service by the Francoists under the designation R6 and assigned to a unit based in Spanish Morocco. The aircraft were used as trainers, and some examples remained in flight until 1955. To this day, only 1 example of the G-23 aircraft has survived. This machine was once sold to Nicaragua, and in 1942, after being decommissioned, it was abandoned near the Managua airfield. In 1961, while spraying chemicals over a cornfield, American pilot John Simone saw the neglected and partially destroyed G-23 airframe. After purchasing the remains of the fighter, Simone restored the biplane to flight condition in 4 years, and in February 1966 ferried it to the United States. The only difference between the restored aircraft and the original was its power plant. Instead of the R-1820 engine, Simone had to install an R-1340 engine with a 3-bladed propeller. Otherwise, the fighter was authentic. Grumman acquired the rare aircraft and, after repainting it as a carrier-based fighter from the Red Ripper Squadron, displayed it in the National Museum of Naval Aviation in the United States. The FF-1 aircraft was a 2-seat single-engine biplane of mixed semi-monocoque construction, with an all-metal fuselage skin, fabric-covered wings, and retractable landing gear. The fuselage of the machine was of semi-monocoque type. Its structural frame consisted of 14 frames supporting stringers and main longerons. The fuselage skin was entirely duralumin. Panels covering the engine accessory compartment were attached with slotted fasteners with a recessed ferry-type head. The panels covering the engine accessory box had slits for cooling air outlets. In the nose section of the fuselage, the engine was mounted on a tubular steel engine mount. The mount was fixed to the first main frame, which also supported the landing gear retraction mechanism. Between the first and second main frames were the oil and main fuel tanks. On both sides at the bottom, the skin had circular openings into which the aircraft's main landing gear retracted. The second main frame acted as a firewall, separating the cockpit from the engine compartment. The pilot's cockpit was enclosed by a transparent canopy consisting of 6 sections. The last section, made of 2 curved sheets of plexiglass, could be folded. Pilot seats were made of duralumin without armored backs and not adjustable in height. An optical sight was fixed in front of the cockpit, with 2 7.62mm machine guns mounted below. A radio station was located behind the gunner's cockpit. On some aircraft, a radio compass was installed. Its antennas stretched between the upper and lower wings. This compartment also housed the distribution electrical box, the onboard first aid kit, an emergency supply of fresh water, and a ration pack. In the rear fuselage section were mounted an arrestor hook, a retractable tailwheel, and the tail unit with its control surfaces. The wing's structural frame was duralumin with stamped ribs. The lower wing consoles were attached to the second and third main frames. The entire surface of the wing had fabric covering. The wing had no mechanization. Ailerons with fabric covering were located only on the upper wing. They had a rigid drive and external aerodynamic balance to reduce control stick forces. The upper and lower wings were connected by N-shaped struts. In addition, the upper wing was braced to the fuselage with extra struts and contained within its cavity 2 inflatable rubber bags to maintain buoyancy after an emergency landing on water. The tail unit had an all-metal structural frame. The fin and stabilizer were covered with duralumin, while the rudder and elevators had fabric covering. The stabilizer had an adjustable incidence angle from 10 to +5 degrees, controlled by a small wheel on the left panel of the forward cockpit. Rudder control was via flexible cables. For additional rigidity, the stabilizer and fin were joined by a profiled strut. The landing gear consisted of retractable gear with a tail wheel and arrestor hook. The gear retraction and extension system was hydraulic with the possibility of emergency manual mechanical extension. When retracted, the struts and wheels folded into special bays in the lower fuselage. The aircraft's power plant consisted of a 9-cylinder air-cooled engine producing 750 horsepower with a 2-bladed all-metal variable pitch propeller of 9 feet 6 inches diameter. To reduce drag, the engine cylinders were enclosed by a town-end ring. The aircraft's armament consisted of 3 7.62mm Browning machine guns, 2 mounted in front of the pilot's cockpit, and 1 on a flexible mount in the gunner's cockpit for rear hemisphere defense.